Hello class, we are Team 25 and my name is Reinout from Landegem and my partner's name is Pikaso Dutta, and we are going to be giving the weekly update presentation for April 18th on our project, which is titled SPY and Sector ETF Pattern Recognition through K-means Clustering and Technical Indicators. Our academic advisor is Dr. Kashana. So for our project, we are going to be studying the volatility as well as the normalized graphs for the 9 sector ETFs that compose the SPY 500 index. We want to identify patterns in the volatility, the returns, and the normalized price graphs using two main methods. The first method we will be using is a time series clustering method, which I will be talking about in more detail, and the second method we will utilize is artificial neural networks, which Pikaso will talk about in more detail. The main question that we are trying to answer for our project is, which of the 9 sector ETFs delegates the SPY volatility and price movements the most? So this past week I have been working mainly on the written report of the project, while Pikaso has been working on the neural network method, so he will be talking about that later on. So here's a brief recap of the first method, which is time series clustering. So the top graph is for normalized prices, and the bottom is for return. So as you can see on the right, we have the cluster groups, which I talked about last week. The main idea from this is that the cluster groupings are very different for the normalized prices and returns clustering, which is something that we will be talking about in our report in more detail and for our final presentation as well. So for next week, we will continue to experiment with the number of clusters as well as adding and removing various ETFs to obtain a more precise pattern grouping. We will also both be working on the written report for next week, and now Pikaso will give an update about the neural network component of the project.
So here we will discuss on the next part of our project, which is on neural network. Just an overview of this part. We calculated the VAR from the ETFs, applied technical indicators to get MACD, Around, and ADX, considering them as the independent variable, and finally regressing on VIX data using RN and LSTM model. So previously we have achieved an accuracy of 46% using ADX in our model. We also used Around but received even poor results. This time we have used a composite indicator using ADX, Around, and RSI, and we have seen that we have received a better results in this case, which is around 68%. In this case, we have lowered down the learning rate to 0.01 and decreased the batch size from 32 to 16. Now we have received some significant number of accuracy to be considered if we compare the graph for predicted versus actual, and we see that there are occasional spikes in the predicted variables compared to the actual one. Now regarding the activation function, we have also tested the sigmoid function while using MACD because the values of MACD are not bounded. So for the purpose of model training, limiting MACD value with a definite range using the sigmoid might be helpful. So finally, we have tested and the function to check if it works well for this type of input data we have now, or do we also need to transform the data. Also, there are a few parameters which we will also test before we implement the model.